let us talk more about the strength of relationships of our variables. Previously, we have learned about the coefficient of correlation, or more popularly known as Pearson R. Now, please do take note of the following. It is possible that there is no linear relationship, but there is still a relationship, because remember that R is more for linear relationship. So there might still be a relationship, but it's not just linear. So the R might be equal to 0. Also, this is a famous saying in statistics: correlation is not causation. It doesn't mean that if R is equal to 0.9, then the cos of Y is actually X. That is not that is not how it is. This is just saying that the relationship between X and Y is strong, that as X increases, Y is increasing as well. Or if R is equal to negative 0.9, this is saying that the strength in which that if as X decreases, Y increases is just very strong. But it does not say that the cos of Y is X. It does not say that one. That one, that X causes Y, is the things that we more look into regression and not just correlation. So we have talked about strengths in terms of Pearson R. We also have another one, the coefficient of determination. This is the square of R. That's why usually if we have R, we also have R squared. This determines the percentage of the variability in Y that may be explained by the linear relationship in X. So, to further explain this, let's compute for the R squared of our running example of dexterity and productivity in Excel. So here we are again in our Excel. And now we want to know the R squared, or the coefficient of determination of our data. So we can select our trend line here. And once you go down in trend line options, or you can also right click, format trend line, and then choose trend line options. Down below you can see display R squared value on the chart. So when we click that, there we go. We have our R squared value of 0.9112. What does this mean? So this would mean that the R squared is 0.9112, or we can also say that this is 91.12%. What does this mean? We can say that 91.12% of the the variation on our Y variable, which are the units produced in 1R, in 1R, is due to dexterity test score. So the reason why, another way of saying this is that the reason why there are different values in our model, 91.12% of the reason why there are different values in our model is actually due to the dexterity test score. So if you have an R value of 0.95 and an R squared value of 91.12%, then based from this, we have a very strong relationship. We have a very strong correlation. We have a very strong correlation. It is positive based on its direction, and the coefficient of determination, that the variation between the data points here, or the reason why there is variation or differences among the score, is because of the dexterity score, then that means that the relationship between dexterity score and productivity is quite strong, based again from our data. That's how we interpret the values of R and R squared, because they are mainly about the strength of the relationship. So now, so far in our simple linear regression analysis, we have already take a look at the scatter plot. scatter plot that shows the visual relationship of our data. We already have our regression line, which shows visually our actual model, which is the regression equation, and we already have determined the strength of the relationship between our two variables by Pearson R and R squared, which are actually saying that this relationship is very strong. However, the relationship might be strong, but the question is it significant? So we're going now to look into the significance of our relationship through hypothesis testing and regression, and we'll look at that in our next video.